we have come to know prior slides what is OFDM technology adopted in LTE. So this is OFDMA access, orthogonal frequency division multiple access, that nothing but single carrier frequency division multiple access. That is generally we are using it physical, uplink channels we are using it. OFDM access in LTE. Any OFDM based standard specify following things in order to specify the word. It must specify the quanta or units of time frequency resource that can be assigned. It must specify message protocol that allows the MS to request resources when necessary and know that resources they can be assigned both transmission and reception. Ranging procedure must be specified so that simultaneous uplink transmission from several different mobile units can be reliably decoded at the base station. While uplink, while we are transmitting, we are using multiple several mobile users we are using or devices that to be uplink. That is the reason we are using this technology, orthogonal FDMA access, technology in LT. Whereas other OFDM technology we are using, OFDM technology, it is in receiver end. The LT time frequency grid. Grid is nothing but cycle prefix which we are using, allotted in the things. The LTE mobile units are allocated group of subcarrier over time frequency known as resource block. The size of the resource block is chosen to balance the trade-off between granularity and the overhead. It is shown in diagram. For example, the subcarriage of any use in any time slot increase very large amount of overhead the specific kernel allocation to all the mobile unit. The structure of LT time frequency grid is given below. You can see that how exactly defined. OFDM and LT. OFDM orthogonal frequency division multiple access which we are using in LT. The typical resource block consists of 12 subcarriers over 7 OFDM symbols, also referred as the time slot. And a time slot LT spans 0.5 millisecond and 2 consecutive time slot create a subframe. So total that the things we are having subcarriers. This week can be seen that resources are allocated to unit of source block over the subframe. 12 subcarriers over 2 into 7, 14 OFDM symbols for a total of 168 resource element, which is practice or QM symbol. Not all 168 resource element can be used for data, but can be used for various layer on layer to control messages also. The subcarrier of the resource block can be allocated to one of the two ways: distributed subcarrier allocations, or it takes advantage of frequency diversity of the spreading of the resource block hop across the entire channel bandwidth. OFDMA third point in LTE. This can be accomplished by using a COM pattern at any given time for a given user, so that its subscriber occurs at a given interval across the entire frequency band. This approach is typically used as downlink OFDMA when distributed subcarrier allocation is used. Frequency diversity can be achieved by hopping the continuous block of subcarrier in time. Frequency diversity achieved as long as sufficient over interleaving is amplified. This is certainly the case of LTE systems which are heavy on interleaving. This approach is used in uplink since single carrier FDMA transmitter in the general operator of continuous set of the subcarriers. FDMA in LTE. Adjacent subcarrier allocation. The approach relies on the channel-aware allocation of the resource so that each user can be allocated a resource block where they have a strong channel. Since the block of 12 subcarriers is typically smaller than the coherent bandwidth of the channels, frequency diversity is not achieved, which is helpful as long as subscriber is able to assign the good blocks of the each user. allocation notifications, and uplink feedback. The LTE uplink notification and feedback signaling between base station to mobile subscriber. Generally, base station, if you call E node B in LTE and MS we are calling in LTE is mobile entity, done by the logical subscriber entity on the logical control channel, especially physical downlink control channels. These signal carriers to use in downlink reception and uplink transfer of MS and base station broadcast information pool to active user in itself. Physical downlink control channels. This is specify the downlink resource block allocation, uplink resource block allocations, quadratic adaptive modulation, constellation of use of resource block, type and rate of coding of user resource block. When the user is able to decode the PD control channels, physical downlink control channel, it knows actually where to receive the downlink or to transmit uplink to how. PDCH is sent over the first 2-3 OFDM symbol to each subframe across all the subcarriers. PDCS uses the 12 to 21% of the total downlink capacity of the PDCS. Additional downlink capacity also used by other control channels and pilot symbol. We are using base station in uplink scheduling. LTE unit utilize buffer status reporting also, whereas each user can notify the base amount is queue length and the channel quality information feedback. OFDM LTE in power control. When the base station is well informed about the channels to and fro from the users and the respective queue length, it can be more appropriately determine the optimum allocation among the various users. The downlink base station is inherent knowledge of the amount of buffer data in each user, while the uplink can estimate the channel from each user. Hence, BSR feedback is only used for uplink scheduling, while CQI feedback is only used for downlink scheduling. Right? So, BSR we are using for uplink scheduling and CQI we are using for downlink scheduling and AMC code selection. CQI in downlink scheduling reporting can be either periodic or aperiodic. It may be periodic or aperiodic, wideband, subband or multiple CQI feedback modes are defined for different scenarios. Power control is the kind of solution utilize SNIR values over the cell and hence control of inter-cell interference in both uplink and downlink. It manages self-interference related to imperfect time frequency power synchronization between different uplink users. Power control, the same continuation of the power control. LTE generally we use closed loop power control in possible to uplink where the base station especially indicate the maximum transmit power density that can be used by each user. Okay. That's all it is. Thank you very much.